So to begin with, I have a list of 2D interarrays called possibilities. This will hold all the configurations, and I add all of the 16 inputs to that list. I then have an integer called selected. It's initialized to 0 for the first item in the list, and this increases each loop for which interarray is grabbed from the list that we'll be working with. I also have a bool called cont for continue, and it's initialized to true. That way the while loop will keep running until the user tells it to stop. The while loop will keep running as long as cont is true, and as long as selected is less than the number of items and possibilities. So the first thing I do in the while loop is I create a 2D interarray called pixels, and I grab the array from the selected index in possibilities. I then display it to the console and use my calculate light dark method to figure out if the configuration is light or dark. I then create a string for the read line and set it to lower, and if it equals q, then continue is false, so the while loop doesn't run again. If continue is true, if they don't hit q, so they want to continue, it checks if selected is equal to the possibilities count, -1 if we're on the last item in the list. If we are, we set continue to false because we don't want to continue, and then we do a read line just to keep the console open. Otherwise, if they want to continue and we're not on the last item in the list, we increase selected and the loop runs again. Down here, my function to display the pixels to the console. First, I get the length of one dimension of the array, and that's the size that I work with. I loop through the rows and columns using the size. If the value is 1, I add space just for formatting, and then I write the value at ij to the console. And I do a new line after each row. A little further down, we have calculate light dark, which takes in a 2D interarray for the configuration. It gets the sum of all the weights by adding each pixel value together. If the sum is greater than or equal to 0, that means there are at least 2 pixels with a value of 1 or a light value, so then the output is bright. If it's less than 0, then there aren't enough light pixels and the output is dark. So as you can see on this one, it outputs the configuration and it says whether it's dark or light, and then you can continue. So I'll just go through each configuration. So to start with on this one, I have a float for the learning rate, which I initialized to 0.1. And then I have selected, which is initialized to 0. That'll be used later in a while loop. I then have a list of int arrays called all inputs, which will be all of the different configurations for the pixels. I then have W0 through W4, which are the weights from each of the inputs to the hidden layer. Inside of main, I have an int for the epochs. I say we're starting on the first one, so I initialize it to 1, and then I have a bool called cont, which is to continue for the while loop later on. I then add all 16 configurations to the all inputs list. I have a while loop that continues as long as cont is true, and the first thing I do in that is set special input equal to 1 for the first input node. And then for the remaining input nodes, I get the value at their corresponding positions in the integer array from the all inputs at the position selected. Then I display it to the console, and then I get a sum of all the weights from the input to the hidden layer. So W0 times its input value plus W1 times its input value, and so on. I then use that sum and plug it into the sigmoid function for the sigmoid weight as my transfer function. And then I let the user know what the sigmoid weight is. I then use 0.25 to check if it's dark or bright, and if it's less than 0.25, that means the observed output is dark. But if the bright function returns true for this array, then the observed output is dark but the target is bright. So I let the user know that it was incorrect, and I get new weights. Otherwise, if the observed output was bright, but it should have been dark, I do the same thing where I use get new weights function. And I use -1 as the target value and 1 as the observed value. Otherwise, if it was observed to be bright, and it should have been bright, then I say that it was bright. Otherwise, then it was observed dark, and it should have been dark, and I say that it was observed dark. I then ask the user to continue or press Q to quit, and I read in that line, and if they say Q, I say continue is false, so the while loop quits. Otherwise, I check if selected is equal to the last index. If it is, I set selected back to 0 so it can run through again, and I increase the epoch number, and then I let the user know that we've gone to another epoch. Lastly, if the user wants to continue and we're not at the last index, then we just simply increase selected and the while loop runs again. So this is my function called bright. It returns a bool after taking in an int array. It says pos equal to 0, which is the number of positive numbers in the array. It loops through each of the items, and if 1 is equal to 1, it increases pos. And then when it's done looping through, if pos is greater than or equal to 2, it means there are at least 2 positive numbers in there. So at least 2 bright spots, so it returns true for bright, and then if that isn't true, it returns false for dark. Down here we have the get new weights function, which was called when the observed output was different than the target output. So first it gets the base error, which is the learning rate, times the target value minus the observed value. And then I use this for each of the new errors. And I get an error value for each of the inputs. So error 0 is for the special input, and it uses error base times 1 because the input value is 1. And for error 1 through 4, it multiplies error base by this specific input value at the selected position in the array. I then go through each of the weights, weight 0 through 4. Those are the weights from the input to the hidden layer, and I add their respective errors to each of them. So as you can see for this configuration, it observed that it was dark, and you can see the sigmoid weight right there. If I continue, it observed this one's bright, and it's wrong, so it adjusts the weights, and you can continue, and gets most of them right. For the 6th configuration, it observes dark, which is incorrect, so it adjusts the weights again. And the same for the 7th. And you can see that we're entering the 2nd epoch. You can see that it's still getting the 2nd configuration wrong, so it readjusts the weights again. And you can see on the 6th configuration, it observed it as dark last time, but now it's observing it as bright because of the adjusted weights. And the same for the 7th. And now we're entering the 3rd epoch. And in the 3rd epoch, it observed them all correctly.